This video is an overview of enclosure door handles for industrial applications, sponsored by Solar Turbines and done by Team Turbine for the SDSU Capstone Senior Design Program. Solar Turbines creates turbo machinery for energy generation. Oftentimes, this machinery comes with an enclosure to protect it from the environment. These enclosures are fitted with a ventilation system which creates a negative or positive pressure differential between the inside and the outside of the enclosure. This makes it difficult for technicians to open and close the enclosure doors during operation. Solar Turbines tasked the team with creating a solution for opening and closing these doors without having to turn off the ventilation system. The main idea behind the mechanism is to use leverage to create a large push or pull force from a small push or pull force, depending on the pressure differential. The leverage values are shown here, and the leverage ratio is also shown in green. The main assembly on the mechanism is shown here as an exploded view with the parts labeled. The most important parts being the L bracket, the pivot beam, and the C channel, as well as the bearings and all the hardware that are involved in securing those to the corresponding parts. Here the mechanism is shown fully assembled. As you can see, the contact bearing is guided using the guidance C channel, and the pivot bearing is bolted onto the L bracket. The long arm of the leverage is connected to the cylindrical pull rod, which is connected to a locking mechanism. As you can see, the assembly is symmetrical about the midpoint. The operation would be as follows. Once the original door handle is open, the technician will use their right hand to hold onto the cylindrical bar and their left hand to unlatch the locking mechanism. This allows the operator to pull or push the bar, opening or closing the door. Now we'll go through an overview of our test rig and mechanism manufacturing. The main idea behind our test rig was to simulate the pressures and forces necessary for our mechanism to operate successfully, using the guidelines given by Solar Turbines, as well as OSHA standards for pulling and pushing while opening doors. The main issues that we had to resolve using this testing rig had to do with air leaks. We were able to overcome these issues by adding gasket around the door lining, as well as extra support along our walls. After a lot of root cause analysis, we were finally able to build up the pressures that were required for the testing of our mechanism. Now we will move on to the actual mechanism manufacturing. The manufacturing started off with water jetting our sheet metal parts, which included the C-channel, L-bracket, and pivot beams. The next step was to bend the metal as well as bore the required holes. Finally, the top and bottom pivot beams were welded to the cylindrical rod. Special thanks to Carlos Verdeja and Team M1 for the help with the welds. Now we will see the manufactured prototype on the test rig. Here we cover the step-by-step assembly of our mechanism onto our full-scale test rig door. Here we are showing the actual operation of the mechanism. It's important to note that we tested our mechanism sideways as opposed to upright. This was done to mitigate any safety concerns with building an upright, gigantic test rig in the backyard of one of our teammates' houses. Special thanks to Mr. Lester in the SDSU machine shop.